All right, 6th grade, I'm giving this another try. I first did it with my iPhone, but I can't get that video uploaded. So I'm going to try it now with my webcam. If you'll get your books and turn to page 108, you can refer to the book as well as the video at the same time. But remember, a quadrilateral is a polygon. That's a flat figure that has 4 sides. So you should have already written that note in your notes at this point. A parallelogram, I would like for you to draw the figure in your notes, and I would like for you to label that figure in your notes. You know, we practiced that today. A parallelogram is a quadrilateral because it has 4 sides. But what's special about a parallelogram is it has opposite sides are parallel, but they're also congruent. These are congruent, the top is congruent with the bottom. That means they're the exact same size. You've got your rectangle, which you know about rectangles all the way from kindergarten. What's special about a rectangle is your top is congruent to your bottom, your sides are congruent with each other, and they're also parallel. That means if I was to extend the lines, they would never connect. They would never intersect. Same way going to the sides, the long lines. They would keep going and never intersect. You've got your square, which is very special because it is a quadrilateral parallelogram. But the special thing about a square is all 4 sides are congruent. The same thing with a rectangle and a square is that it has 90-degree angles. And you can see right here, these are 90-degree angles. We learned about that in previous lessons. And the next shape is a rhombus. And what I consider a rhombus is kind of like a square slanted. But rhombuses also have congruent sides. So it's like all 4 of those sides are the same, just like in a square. But they're slanted. They do not have 90-degree angles. And last but not least, the trapezoid. A trapezoid is a quadrilateral that has only 1 pair of parallel sides. So this would be your trapezoid. I like to draw the bases first, then I connect the bases. These are your 2 parallel lines, and they're not congruent. So for any of these quadrilaterals, what we have here, you have to remember that all of these are equal to 360 degrees. And I see that it's writing backwards on the board, so I'm just going to remember this is 360 degrees. And if you would please make a note that all quadrilaterals equal 360 degrees in your notes. If you look at your book, you can see they drew a purple shape. I will erase this. The purple shape is a quadrilateral. It's written like that. And as you can see, they did a little dotted line, kind of splitting it up to be 2 separate triangles. We have a triangle here, and we have a triangle here. Well, we know that triangles are 180 degrees each. So this is 180 degrees. This is 180 degrees. 180 plus 180 equals 360 degrees. So this whole quadrilateral is going to be equal to 360 degrees. Now for any parallelogram, for a square, now it's obvious right here, if you'll continue in your book, it says it's obvious for a square or rectangle since 4 right angles add up to 360 degrees. We know if we're looking at a square or rectangle, this is 90 degrees, this is 90 degrees, this is 90 degrees, this is 90 degrees. If I go 90 degrees times 4, I'm going to get 360 degrees. That's obvious. But this right here is a little bit less obvious. But I split it up into 2 triangles. And you know this is 180 and this is 180. It's just causing you to think about the shapes in a different way. You should be writing all of this down in your notes. Our next point is For any parallelogram, opposite sides have the same length and opposite angles have the same measure. This is important for us to understand because it will help us to find missing information. So they drew, looks like a rhombus. No, that is just a parallelogram. They drew a parallelogram. In your book, it's that purple one, and they labeled it A, B, C, D. You should label yours too. You should draw it. You should label it. It's saying this and this line is parallel to each other. I mean, it's congruent, the same lengths. And these lines are congruent with this line. Also, it's showing you that this angle is congruent with this angle. We use one little curve. And this angle is congruent with this angle. We use two curves. This is how we write it, and you need to know how to write it. You need to look right here in the book on page 108. In a purple bubble, it says DC is parallel to AB. Also, AD is parallel, congruent to BC. Congruent. So this one is congruent with this one. This one is congruent with this one. That's how we write it. You have to be able to read what you write. Also, we've got angle A is congruent to angle C, opposite angles. Angle D is congruent to angle B. I know this is backwards because the video is capturing it backwards, but if you look in the book, it's written perfectly for you to be able to see and understand. So, if I know that this measure right here is 50 degrees, if this angle is 50 degrees, I know this C is 50 degrees too. Well, what do I know about all quadrilaterals? All quadrilaterals equal 360 degrees. So, just like we did today with triangles, you've got 100 degrees here. So that means these two angles right here are going to equal 260 degrees. So now I've got to split up that 260 degrees between the D and the B. I'm going to divide it by 2 and get 103, bring down my 0, 130 degrees each. This one's 130 degrees. This one's 130 degrees. Now I have figured out how many degrees each little angle is. That's what the book is trying to show you right here on page 108.